This is an example of a hypothesis test and confidence interval for the difference of two population means with independent samples. And the data for this problem is in Chapter 9-74 in our StatCrunch group. A student asked samples of surfers who own longboards and surfers who own shortboards how many days in the last month they had gone surfing, and the data is recorded in the StatCrunch Chapter 974. Use the data to test the claim that the mean days surfed by the two populations are different, and then we'll construct the 95% confidence interval for the difference in the population mean days surfed by the two groups. How does the confidence interval support the hypothesis test conclusion? Okay, so we're going to start the hypothesis test process by writing our null and alternative hypothesis. And the question we were asked is, are the mean days surfed by the two groups different? And again, the hypotheses are about all longboard surfers and all shortboard surfers, not the ones that are sampled. It's going to be clear looking at the data which group surfed more days than the other. But the question is, does this sample give us enough information to conclude that the populations, that all longboard surfers and all shortboard surfers surf different amounts? Okay, so let's write that in symbols. Again, this is comparing two means, so we're using the symbol for mean. And one group will just make population 1, or you can use letters if you'd like. We're going to compare the longboards with the shortboards. And the question is, are the longboard mean and the shortboard means the same, or are they different? And the symbol for different is a not equal sign. In the second part, we have to see that the conditions are satisfied. Now, the conditions for this problem are that the sample sizes have to be larger than 25, or the population means have to be normal. So when we look at the data, we'll just check that that's true. But I think that when we look at the data, we'll see that the sample sizes were large enough. In our third step, we're going to compare and compute a test statistic. And again, because this is a mean problem, it's about a t-statistic. So the pathway that we're going to use, and again, I'm not going to navigate to there now because it'll erase all of my writing. So I'm just going to talk about what the pathway is, what the results are. And then when we do the confidence interval, I'll show you how to get these results, okay? So we're going to go to stat, and then it's t-stats because we're working with means. We have two samples. And this time we have data, because you're going to see the data in a table. If we were given the given the sample means and given the sample standard deviations, then we would say we had a summary, okay? And we have independent samples. So this is the pathway we're going to use to get our test statistic. But when we do that, our test statistic is going to turn out to be 2.11 with a p-value of 0.04. Now, a p-value of 0.04 means that our sample would be highly unusual if the population means were the same. And so we don't believe the population means are the same. We're going to be rejecting our null hypothesis. And our conclusion is going to be that the mean days surfed by longboard and shortboard owners is different. And then we're also going to be doing a confidence interval as well. So let me navigate to StatCrunch and show you how we got these results for the hypothesis test, and then also do the confidence interval. Okay. So here's the data. You can see I brought it up here. We're going to come here to stat, t-stats. We have two samples, and we have data. Okay, the values in the first group will make the first group the longboards, and the second group the shortboards. And you may wonder, does it matter? And the answer is no, it really doesn't. Okay. So we're just asking whether they're the same or whether they're different. So we have a not equal sign in our alternative hypothesis. And now we'll compute. And so we see our test statistic of 2.1 and our p-value of 0.039, or I rounded off to 0.04. All right, so now let's do the confidence interval. So I'm going to edit this. So it's the same path to the confidence interval, except instead of choosing hypothesis test, use confidence interval. Now it's going to be important that we remember which is which. So our first group are the long boards, and the second group are the short boards. Okay, and now we'll compute. And we have a lower limit of 0.13 rounded off and an upper limit of 5.1. All right, so let's record that and talk about what that means and how it supports our confidence interval, our hypothesis test conclusion. So our confidence interval turned out to be 0.13 for the lower limit and 5.1 for the upper limit. Now, what this interval represents are the possible answers we would get if we took the mean of the long boards and subtracted the mean of the short boards. What possible answers could we get? And what this tells us is these are the possible answers we can get. All right, so the possible answers we can get, first thing to notice if they're both positive. Now, what does it mean to be a positive number? Well, we know that positive numbers are numbers which are greater than 0. So the confidence interval lies on the right side of 0. And what this means is that 0 is not a possibility when you subtract these two numbers. And if 0 is not a possibility when you subtract these two numbers, that means that these two numbers must be different. And that was our conclusion to the hypothesis test. We were going to reject the null hypothesis, and we concluded that the mean number of days surfed by these two groups was different, and our confidence interval confirms that. And just a reminder, a confidence interval will always confirm a hypothesis test. If you're ever doing work and you think that you've contradicted the hypothesis test, go back and recheck your hypothesis test, because probably you made the wrong conclusion.